Hi folks, great to be here, and I'm here to talk about combining Postgres and ClickHouse to build a unified data stack. And before I get started, I'll quickly introduce myself. I did this like in my previous talk, but I'll still do it because there could be a few new folks. I'm Sai, and I lead all the Postgres efforts at ClickHouse. And prior to ClickHouse, I was the co-founder and CEO at PeerDB. PeerDB was a data replication tool which was built with laser focus on Postgres. And ClickHouse acquired PeerDB around like 2 years ago, and that's how I joined ClickHouse. And prior to PeerDB, I was working at Microsoft, and I was in the Azure Postgres team. I worked for like 4 or 5 years, and I have a bunch of like ex-colleagues and amazing friends who are outside. And prior to Microsoft, I worked at a database startup called Citus Data, which built a distributed Postgres database. I was an early engineer there, and Microsoft acquired Citus, and then that's how I joined Microsoft. So yeah, so my life in the past decade has been mostly around Postgres, ClickHouse, open source databases. So yeah, so excited to be here. How many of you in the audience know or have heard about ClickHouse? Everyone. I mean, like, amazing. So that's great, and I remember that like a couple of years ago when I used to like do a talk, it was like around 10% used to raise their hands, and now I see that it's like almost 90% raise their hands. So like that's quite a good job from our like marketing team. So yeah, ClickHouse is an open source column-oriented distributed OLAP database. It started as a project in 2009, went to production in 2012, and was supporting the second largest like web analytics platform in the world. And it was open sourced in 2016, and since then many companies have adopted like ClickHouse. This includes Netflix, Instacart, Meta, Anthropic, and thousands of like companies. In 2021, ClickHouse INC was formed, and the idea was to make it easier for customers to deploy and manage ClickHouse in the cloud. ClickHouse is a column-oriented database with many specialized features and optimizations for blazing fast analytics. It is distributed. In open source, it comes with sharding, and in the cloud, it comes with separation of storage and compute architectures. It supports like both multi-master and cross-region deployments as well. And last but not the least, ClickHouse is purpose-built for analytics, supporting aggregations, real-time visualizations on massive data sets. I see Postgres and ClickHouse have quite a lot of synergy and similarities between them. They are both open source databases purpose-built for two different use cases: Postgres for transactional OLTP use cases, and ClickHouse for analytical OLAP use cases. And I'm sure you know how cool like Postgres is. It's the most popular open source transactional database. It offers rock solid support for features such as transactions, including low latency CRUD operations, ACID compliance, indexes, a rich SQL interface which lets you run any query, a robust extension framework, and a vast ORM and application ecosystem, making it the default backend for like most of the web and AI applications in the world. ClickHouse, on the other hand, you can think of it like Postgres, but purpose-built for analytics. It is the fastest analytical database on the planet. It offers like purpose-built features, including columnar storage, skip indexes, incremental materialized views, distributed cache, native JSON and full text search capabilities. We recently launched like JSON in ClickHouse, and each of the columns are also compressed in like ClickHouse. And I'm sure you folks know the cool JSON-B and JSON capabilities in Postgres, right? So now you can store semi-structured data even in ClickHouse, right? And then we also introduced lazy materialization, which makes like aggregations, group bys even more optimal, basically, right? And this complements vectorized execution, columnar storage, and all the analytical features. And there are hundreds of such features, making it like super purpose-built for real-time analytics. Both of these databases evolved from the same ethos of open source and have large developer communities around them. This kind of synergy is playing out even in the customer community. There are thousands of companies who use like Postgres and ClickHouse together to form their data stacks. This includes companies like GitLab, Instacart, CloudFlare, LangChain, and thousands of such companies. And I love this blog post from Sid, who talks about how two sizes fit most, which is PostgreSQL and ClickHouse. And the use case that we see, right, is you have a real-time customer-facing application where you start building on Postgres, basically, right? And within few months, as your data grows, you see that there are performance and scalability issues for analytics, right? Which is when your dashboards become slow, etc. Which is when you adopt a ClickHouse, which is a purpose-built analytical database, right? And offload your analytics to ClickHouse. So it's still coexistence, right? Like, I mean, you have transactions getting powered by Postgres, analytics powered by like, ClickHouse, and your real-time application is much more scalable, much more performant, etc. With the like in the world of AI, what we are seeing is this kind of architecture is like it's trending a lot, and we are seeing a sudden surge. And there are two reasons for that. First is number one, like the amount of data, right, like is growing very, very quickly, right? Like back in the day when I was working at Citus Data, which was also built for real-time analytics, right? Postgres outgrowing, right, was probably 1-2 years affair, right? But then with now, because of AI, right, that's happening within few months, right? And I expect that in the coming like future, right, you need to think of like scale from day one, basically, right? And the second is these AI native applications. For these AI native applications, intelligence and analytics is very critical, right? Like, I mean, without that, like, it's kind of meaningless, right? You're building a HR platform and you just like provide like CRUD. That won't make sense, right? You want to know where are my like recruiting, where are my like candidates coming from, like AI like features around it and all of that, and that's all analysis basically, right? So the prominence of intelligence and analytics is growing, right? So we are seeing that like need of ClickHouse to come much sooner. So here is an example of what customers typically do when they adopt like ClickHouse, right? This is a sample like Postgres plus ClickHouse architecture, right? You have Postgres on one hand, and by the way, this architecture is from Instacart, right? And they are also like a Postgres plus ClickHouse user. You have like Postgres on one hand, you have ClickHouse, you have external pipelines with a combination of Debezium, Kafka, Flink, right, like for transformations, right? And then there is one thing that's not captured in this image is you have an application layer which needs to be aware of both these databases, right? Like Postgres on one hand, ClickHouse on the other hand, right? Like, so your application needs to be aware that, okay, you route your transactions to Postgres, analytics to ClickHouse, right? So to merge both of these databases, it's at least like few months to like, an year of effort, right? Like with large, like, data engineering teams, right? So keeping this in mind, what we are doing now is with our most recent announcement, we are bringing Postgres into the ClickHouse cloud umbrella. We are providing a native Postgres managed service within ClickHouse, and the idea is it is very deeply integrated with ClickHouse, right? Customers get like best of both worlds, like Postgres for transactions, ClickHouse for analytics, with no operational overhead, right? Like all the data pipelines are like all eliminated, and like it's all we have native CDC capabilities to start syncing data from Postgres to ClickHouse, and then we have a unified query layer which enables applications to just query that like unified query layer, right? What we'll do is I want to double click into this architecture, right? So let me take you to this particular link. So here is a GIF. So what does this come with is, if you see, so this is the architecture, right? And it comes with, first, the Postgres itself is very fast, right? Like the Postgres managed service is backed by NVMe storage, basically. And NVMe storage means that the storage is co-located with compute, right? So it does not require like operations like CRUD, upserts, vacuums, checkpoints, don't need like a round trip for disk access, right? It's all co-located with compute. So these disk-bound operations, which are very frequent in OLTP, right, like are very, very fast. And I'll show some benchmarks which show the power of NVMe, right? So the Postgres managed service itself is very fast and scalable. That is one. And then the second set of features is integration features, right? It comes with basically blazing fast replication, right? So within a few clicks, you can start like syncing your operational data to ClickHouse, make it analytics ready, right? So that is one feature, and I'll go into like how that piece is enterprise ready, right? It's not a toy software; it like actually works at scale, right? So I'll talk about how we are like making it like make that happen, right? So that is one. You get like one click like replication from Postgres to ClickHouse, which is enterprise ready, and then you have a unified query layer which enables you to run both transactions and analytics, right? So we built this extension called PG-ClickHouse, which enables you to run queries on ClickHouse from Postgres, basically, right? So you can actually, use the analytics. You can use the Postgres interface itself for analytics, but use the horsepower of ClickHouse, right? So the idea of all of this is eliminate like all the traditional overhead, like the pipelines, the application or complexity, and make it like very, very magical for customers, right? And let's like go back to the slide, and I'll show you. Let's double click into each of these, right? Like first let's look at like NVMe-backed Postgres, like how fast it can be, basically. So if you look at this is something that I already covered, right? Like where if you look at NVMe-backed storage versus network-backed storage, right? NVMe storage does not require a round trip for disk access, right? Like so your vacuums, your checkpoints, these auxiliary processes, as well as like your upserts, updates are much faster. And then you have basically similar compared to EBS-backed storage or S3-backed storage, right? Like it's much faster, right? And then if you see that like graph, that is an example of P99 latency. So once you switch from external like other Postgres providers to like NVMe-backed Postgres, which is like Postgres managed by ClickHouse, your P99 can like drastically fall. We have just launched this service in in the past month, and we have many production migrations, and we are seeing the price performance to drastically reduce as well. So we recently had a customer who was running on an 8x large on RDS, I guess, I don't remember, and now they are using Postgres managed by ClickHouse. They are running at like 2x large or like 4x large, around like 2x to 4x cost savings, right? So there is a price performance difference as well, and this is more prominent for fast growing workloads, right? Like so where you are disk bound. Obviously if you are like using a few MB or like a 1 gig Postgres database, the impact might not be as significant. But once you're in that hundreds of gigabytes, right, and your workload is disk bound, you would see this kind of impact, right? Here are some benchmarks that we ran compared to RDS and Aurora, right? And Aurora is S3-backed storage, right? It's a separation of storage and compute, and RDS is EBS-backed storage, right? And this was again an IO intensive workload, right? We ran a PG bench with a few terabytes of data, right? And if you see it was around 5x faster, right? So and by the way, I have a link which shows exactly what we did, right? So you can try to reproduce this as well. We want to be super transparent on that, right? Because before benchmarks, before I share benchmarks, I want to be really comprehensive. So I shared a link which actually gives you the exact PG bench commands, exact the setup, right? Which region, which availability zone, blah blah blah, right? So now one challenge with NVMe, right, is if storage is co-located with compute. So if the node goes down, my storage is gone, right? So how do I get the same enterprise grade features, right, which is high availability, backups, right, all of that. So there is no compromise on that. First, it comes with cross AZ HA with up to 2 standbys, right? So you have 2 standbys that are spread across availability zones, and we have quorum based replication, and our state machine detects failures, and it's all automatic for you, right? And then you can choose whether you want 2 standbys, 1 standby, or 0 standbys based on your use case, right? For super mission critical workloads, you go with 2 standbys. For semi mission critical workloads, you can go with 1 standby, right? And for dev and staging environments, you go with a no standbys, right? So you have that flexibility as well. Second, it comes with continuous backups with wall archival to S3. So we take a periodic backup every 24 hours, and that's also configurable. If you want, we can do it every 6 hours, every 8 hours. So that's also configurable. And then we ship the wall continuously to S3, right? And this is what powers our point in time recovery and forks feature, right? Where you can go and specify, okay, in the last 1 week, this is the point at which I want to create a fork. That feature is also supported, and all of this orchestration is taken care by the database itself, right? Another unique feature is each of the customer cluster is fully isolated across VPCs, basically, right? So the image that you're seeing here shows you how we do that, right? So for our data plane, we don't use any container orchestration. We don't use Kubernetes, etc. It's raw EC2 VMs, right? it's very like bare and like, you know, EC2 VMs in their own VPCs, right? So that's also one like very big difference, right? Like, because there is absolutely no scope of, you know, one customer data like interfering with other customer data. So that's one very big difference, right? And also we support like the standard features like private link, SSL based, like, you know, authentication, cert based authentication, all of that, right? Our backups are also like encrypted, our the storage is also encrypted, right? And last but not the least, like, note that like there is also ClickHouse Cloud Trust, right? Like, because all of this Postgres is deployed in the AWS accounts with like very stringent policies of our like ClickHouse Cloud, right? Like, and ClickHouse Cloud, you know, we have 3,000 plus customers on our OLAP like, you know, engine, right? So we are following the same security posture as much as possible for the Postgres like managed service as well. So TLDR, you get, you know, an enterprise grade like Postgres service, which is backed by NVMe's for scale and performance. Now let's double click on the second like value proposition. This is like, you know, one of the biggest value proposition, and this is what we talked about, is like native integration with ClickHouse, right? So there are two components to it. First is it comes with, you know, native Postgres CDC, right? And if you see, like, we use PeerDB under the covers, and PeerDB has been like battle tested for like over 2 years now, and it uses logical replication under the covers, right? And you can think of PeerDB as Debezium, but super duper optimized for Postgres, right? Like, so we have like hundreds of optimizations in place to make like CDC enterprise ready and like make it very seamless for the user, right? For example, a feature that I want to call out is we have parallel initial load, where we like, you know, if you have a large table with like 10 terabytes, we logically partition it based on like CTIDs. CTIDs are like pointers to tuples, to rows at the physical like storage layer, right? So we logically partition it like based on these CTIDs and parallelly stream these partitions to like ClickHouse, right? And then tomorrow I'm giving a talk on what all we do there, right? Like we have a very robust state machine which, you know, takes care of like retries, idempotency. What I mean is, if that parallel initial load for whatever reason fails, right, it crashes, right, we can recover from where it failed, because we keep track of what partitions are like, you know, replicated and what partitions are not, right? So the state machine is very solid, where, you know, there is idempotency, retriability. So tomorrow I'll go into that state machine. So there is a talk at like 10:50. Please do attend, and that's not a sponsored talk, so you should like attend. And then we also support like Postgres native monitoring, right? Like, now whatever be it, logical replication has caveats. We started a company around it, so like it has caveats. So basically, if there is like slot lag for whatever reason, you have long running transaction, we basically send alerts to based on to Slack or email, right? We also show you wait events, right? Okay, your start replication is getting throttled on IO, whatever, right? And then PeerDB is actually used by 600 plus customers in production, and they are moving over 300 plus terabytes of data. This is just CDC data, not initial load. Initial load will be another like 100, 200 terabytes. So TLDR, right, the native CDC capability that I was talking about, which I will show in the demo as well, is battle tested and enterprise grade, right? Then the second, and yes, I do want to touch upon what is our roadmap for Postgres CDC v2, right? We want to take like this replication and CDC to the next level, right? Currently, it takes around like the replication latency is around 5 to 10 seconds, right? We want to get that to sub-second, right? For that, one of the feature we want to add in PeerDB is logical replication v2, right? This will let you consume in-flight transactions, right? Standard, by default, we consume transactions only when there is a commit, right? But then this will enable consuming in-flight transactions, by which you get better throughput, better latency, and more importantly, better slot flushing, right? And I wrote a blog, I mean, Kevin, he's right there. He gave a talk last time in PGConf India, which compares logical replication v2 with v1, right? And then the kind of impact that has is very incredible. The slot flushing is much more efficient than logical replication v1. So we want to get that to PeerDB. And this is not very trivial because the target is ClickHouse, right? Like, and we need to take care of transactional consistency, etc., right? So that is one. The second is we want to build a custom decoding plugin to overcome issues of PG output, right? Like PG output is single threaded, where like we consume the slot through a single thread. There are other issues where schema changes are like not great, etc. So we want to build a custom decoding plugin which overcomes those issues. For example, we can do parallel, if possible, we want to do it, consume the slot in parallel, because for most customers like table level consistency is okay, right? Like, so those kind of, features also we plan in the logical decoding plugin. Then we will continue doing upstream contributions to Postgres. Like Kevin right there did like a bunch of like contributions, critical contributions. He was at FOSDEM and like gave a talk about that, right? We will continue doing that. Like this includes like faster initial loads in logical replication, better schema changes. For example, Postgres does not send these not nulls, right? Like you add a new alter table add, right? Like it does not send like this, okay, you define the column as not null, right? Stuff like that we want to contribute to core. So the second value proposition is, now that your data movement is sorted, right? You're replicating your transactional data to ClickHouse and made it analytics ready. Now let's query like both these systems very seamlessly, right? Which is where we have the PG ClickHouse extension. This extension enables you to query ClickHouse from Postgres, and the idea is it minimizes app and query migration, because applications can still use the Postgres interface for both transactions and analytics, right? And this PG ClickHouse extension also is basically optimized in a way that we push down as many constructs as possible. So currently it supports push down of filters, joins, like group bys, subquery, filters, joins, group bys, aggregations, functions. All of these are pushed down. If you see in TPCH, 12 of the 22 queries are fully pushed down, and in ClickBench, right, like all the queries are pushed down, right? And while building PG ClickHouse, we ensured that we build a foundation for continual query, like push down capabilities, right? So down the line we want to add a push down for like CTEs, window functions, and more complex queries as well, right? So the approach we are taking with PG ClickHouse is different from other extensions, right? Like we are not shoehorning a database into Postgres. Postgres is an OLTP database. Let's keep it that way. Like here we are talking about it supporting like mission critical use cases, right? So we are not shoehorning like an embedded database into like Postgres, right? We are keeping it separate, right? And then we are yielding the most out of ClickHouse for analytics, right? So that is one different approach, where like we didn't embed anything into like Postgres, like it's all we are using the raw horsepower of Postgres, right? Of ClickHouse, and you keep Postgres for transactions, right? So here is an example of without PG ClickHouse and with PG ClickHouse, right? So this is a ClickBench query which has an aggregation, right? Like we are sorting based on that aggregation. If you see, it was I think on 100 gigs of data, like it was around 25 seconds on Postgres. But then with PG ClickHouse, right, like where that entire query is pushed down to ClickHouse, it fell to around 479 milliseconds. So there is around 50x performance improvement. This can change based on queries, but at a high level, this is the kind of analytics benefit that you can get using PG ClickHouse. So with that, yes, very whole query we rewrite and send it to ClickHouse basically.
It's not like the Citus extension, which will have a separate process inside Postgres.
Yeah.
It's not like that, right?
Citus is also kind of similar, because like there is a concept of worker node and like coordinator node. The coordinator node basically does the planning, right? But that planning is more intense than foreign data wrapper, because that planning in Citus, like it needs to take care of distributed deadlocks, right? Like there are like, it's more complex basically, right? So in summary, Citus also tries to minimize the load on the coordinator, but this is even more minimal on Postgres.
But this is going to an actual ClickHouse DB, right?
Yes, yes, not inside Postgres. In Citus also the worker nodes are separate Postgres databases basically, right? So yeah.
But correct, but actually when you install Citus there, but this is a separate DB for Citus. It's actually running inside Postgres only.
It's running inside Postgres only, but then your actual work is happening on the workers. It's a sharded database, right? Do you understand?
Yes.
Yeah. Any other questions?
And any difference in the response time when we directly go and meet ClickHouse DB directly?
Yeah.
Through this PG.
Great question. Let's do that. I mean, let's keep it interactive, right? Let's go to, oh my God. Let's go to ClickBench. And then I can't see it. Okay, let's go to, let me search. PG ClickHouse, and then we'll look at ClickHouse itself, right? I had a slide, but I removed it. 1 second. Okay. And then if you see, I want to scroll, let's scroll down, right? And if you see, let's remove the 48x large. That doesn't make sense. Let's just put 4x large, right? Yeah, 4x large. Let's remove the 48x large. So if you see, right, like the performance difference is very minimal, basically, right? ClickHouse is still faster. I mean, obviously you're going native, right? Like it will be faster, right? But the difference is like minimal, right? This can change based on the queries as well, right? Like, but yeah, the entire like idea with PG ClickHouse is it should be as close as possible to ClickHouse, right? So, yeah. Okay. Yes, go for it. Yeah, great question. So as of now, users needs to control it, right? Like, and I'll show the demo will actually show you PG ClickHouse in action as well. But down the line, we want to like basically make it automated, right? Like where transactions go to Postgres, analytics go to ClickHouse. The reason we are not doing it yet is because, you know, PG ClickHouse has to still evolve, right? Like we need to add more push down capabilities, right? Like I mean, the way ClickHouse operates is we try to really focus production and enterprise grade workloads, right? Like, so we don't want to have this magic tool that doesn't work in production, right? Like, so currently you need to configure it yourself, right? Like which queries go and stuff, but still the interface is the same, right? But down the line, we will go to that stage where it's full magic, where like, we route transactions to Postgres, analytics to ClickHouse. So, yeah. Okay, let's get to the demo. I think that's the fun part. Can I, I'll do mirroring basically because I think it will be easier for me, and you'll see all my script, but that's okay. So okay, now I'm mirroring, right? So what I'll do is I'll first go to ClickHouse Cloud, right? So ClickHouse Cloud, as you see, when you now go to, so currently this is behind a feature flag, so like you can join the waitlist and we will enable it to you. So you go to new service, right? So this is where like Postgres is sitting right beside ClickHouse, right? And then you click on Postgres, right? And then if you see it comes with, it currently supported in AWS, we are adding GCP very soon, and then later Azure, right? It comes with 3 like versions, which is 16, 17 and 18, all the 3 latest versions, right? And then it comes in 11 regions, and we can add a region pretty quickly, right? So if there is any region that you don't see here, you can let us know and we can add it. Recently there was a Seoul region where a bunch of customers requested and we added it in a day, right? And then it comes with like different flavor profiles of NVMEs, right? Starting from close to if you see 59 gigs of storage basically, right? Like with one CPU to 60 terabytes of storage, right? With 96 vCPUs, right? So we give you a bunch of profiles that you can provision, right? And then here is where you configure like 0 standby or one standby or 2 standbys, right? And then I won't do that because like it will take some time. So I already have a Postgres instance, so which is called as demo PG, right? And then this one, if you see, has like we show a bunch of metrics, and this is going to only improve. I don't know you folks attended my previous talk. I showed you PG stat ch, right, which actually gives you the kind of operational visibility that all will come here basically, right? So it's just like a patient's game. Within a month it will come, and then we already give you like around 12 metrics, right? If you see here, right? And then let's go into the fun part, which is ClickHouse integration, right? So here before that, let me go ahead and Postgres docs. Let's go ahead and first connect to the database. So you get the connection string, standard stuff. It comes with PG bouncer also in port 6432. One insight I want to say is that PG bouncer is also kind of multi-threaded. So we have 8 peers of PG bouncers that are running basically. So you won't get throttled, right? So and we recently had a customer who had 10,000 connections, right? So I don't know why they have 10,000 connections. That's a separate story, but like it does scale, right? So let's go to the URL, right? And then what I'll do is I'll connect to the Postgres database. I don't have any tables, right? But I do have the PG ClickHouse extension, right? Like which is right here. I'll come to that soon. Now what we'll do is we'll go ahead and create a few tables, right? I have two tables, which is I'll switch on timing also. I always like to see performance parallelly. I have two tables like events and users, right? And let me go ahead and load some data first into the events table. Basically, I'm loading a million rows, right? Just to for the sake of this demo, it took around 3 seconds. And then I'll load the users table as well. So if you see, I have like around /dd plus. It has around like some amount of data, 144 MB and like 88 kilobytes, just to show the idea, right? I have these two tables created. Let's go ahead and run a query, right? A simple query, right? I'm just counting the events based on their event type, right? And it finished, right? Next, what we'll do is let's go back to the UI, right? This is my favorite feature, which is the ClickHouse integration, right? So this is the native CDC that's like all within the product experience, right? So let's go ahead and click on replicate ClickHouse data, right? I'll call this as sync to ClickHouse. I'll just say maybe sync transactions to ClickHouse. I'll choose my ClickHouse service. I'll wake it up. It will take like 2-3 seconds basically. So ClickHouse OLAP also has auto scale, right? So if your database is idle, it sleeps, right? So it's a pretty cool feature. You can save costs, right? So within 20-30 seconds it should wake up and then we can continue, right? And then if you see, there are 3 modes, like we have initial load plus CDC, CDC only, and initial load only. This is kind of self-explanatory, right? Initial load plus CDC is get my existing data and also do continuous load, and CDC only is like just do CDC, right? So I'll move ahead. It already woke up my ClickHouse service, right? And this is where I will show you the tables. They should pop up, right? If you see in my public schema, right, I have 2 tables, which is events and users, right? These were the tables that we want to replicate, right? And then here we provide a lot of data modeling knobs also. You don't need to do it already. It's very like defaulted to the right things, the types, etc. are like very optimal. But you can say that preserve null values from source, right? Like if your Postgres has like null values, you can preserve it in ClickHouse. ClickHouse, they like by default it's not like null. You need to define a nullable thing, right? That's all taken care by replication, right? So I'll choose events and users. Here you can do column level settings also, right? Like if there is some PII data that you don't want to replicate to like your analytical store, you can remove it, right? You can also do other things like basically advanced settings where you can define the table engine, right? Like merge tree, replacing merge tree, etc. You can also specify custom sorting keys and all of that, right? By default everything is good, but like we give that configurability, right? Because we want to keep it very real, right? Like you want to make most out of ClickHouse, right? And then let me click on replicate data. So here I'm okay, let me choose my database. So I did not choose that. I'll choose my default database. I'll also rename these to, I can rename the tables also on ClickHouse. I'll call it as users and events, right? So that they're more straightforward. Let me click on replicate data basically. So yes.
By default, logical replication won't sync sequences and schema changes.
Yes.
It's also applicable here.
Schema changes are supported out of the box basically. So we add columns, drop columns are supported. Sequences not required, not very important when you're doing from Postgres to ClickHouse basically, right? Like in ClickHouse the data is getting as is, so you don't need a sequence basically, right? But for schema changes like add columns, drop columns, we already take care of it because PADB has logic to take care of that. Even though logical replication does not provide it, it gives you relation messages when there is a new row with a new column, right? We use that relation message, do a diff between like source and target, and then replay that like new column change basically. Oh, here you can do anything. You can do anything basically. So you can rename the tables to, if you see, I renamed the tables, right? Public underscore event, whatever you want you do. Because now this is logical decoding, guys. This is not logical replication, right? So because target is Postgres, now ClickHouse, not Postgres, right? So okay, so now this is all ClickHouse, my OLAP database. And if you see, like while I answered the question, it's already done, right? So let's go to the my ClickPipe. So this is the ClickPipe. This is all the PADB experience in the cloud, right? And if you go to tables, I have 2 tables, events and users. And if you took if you see, it took 10 seconds, 5-10 seconds to like get all my million rows, right? And then if I click this events table, right, I can see my like events data from Postgres that is getting into ClickHouse, right? And I'll even like for the sake of fun, right, I'll even add like say 1000 rows to events, right? And within the refresh interval I set is 60 seconds. You can configure it to like less than 10 seconds as well, but that also will be replicated very soon. We'll see it as we go forward, right? And then refresh interval is the sync interval, how periodically I want to sync to ClickHouse, right? That typically customers, the scale at which it works is 5-10 seconds, right, realistically. But with that CDC v2 roadmap that I showed you, we want to get that to sub-second, right? So that's the idea. Now let's go and do the PG ClickHouse, right? And this kind of ties into your question, how do we, is it automatic or you need to configure? As of now, you need to configure, right? So first I'll, I create like a foreign server, right? I go to this and create a foreign server, right? I'm giving my ClickHouse, information basically. And then I create a user mapping, right? This is a test database, so like password is okay. I create a user mapping which actually, shows my default username and like, the credentials, right? Then I'm going to create like my analytics schema, which is, if you see, my analytics schema is there, right? Like this is where I will have my events and users tables, which are foreign tables, right? Then what I'll do is, this is the magic command. I just like import foreign schema default from server ch to analytics. So what this does is, in my default database in ClickHouse, whatever tables are there, go ahead and create those foreign tables on ClickHouse, basically, right? So this all did the magic. So like, let me go to set search bar to analytics, right? And if you go and see this, you have the, I'll reduce the size, but like you have the you have the events table and you have the users table, basically, right? You have this internal table because like we also have for CDC, we have like some table that we have, for our internal cataloging, etc. But in that import foreign schema, you can specify which table you want also. Here I got my whole database, okay? And if you go and see the, events table, it actually, this all schema mapping, right? Like if I go here, all the schema mapping is done by the extension itself, and it tries to keep it as native as possible. So if you see here, like it has integers, it has big ints, it has like timestamps, booleans, etc., right? Now let's go ahead and run one count star on the events table on my foreign table, right? Like basically, right? So if you see this finished, and yeah, my 1000 rows are there. If you remember, I had ingested in my Postgres table, right? And that got replicated, and now I'm querying that table in ClickHouse from Postgres itself, right? So if I do public.events, this is querying my transactional table, basically, right? And then let's go ahead and run explain verbose. If you see, this is the query that it is generating under the covers, right? So it's actually querying my like default database and the event schema, events like table, right? Let me go ahead and run this query on ClickHouse. Obviously it will run and get me the result. So I'll go ahead and run this, and it basically finished, and like it's like showing what's happening on ClickHouse, right? Now let's run a query where I'm doing some kind of aggregation on these like million rows, right? So here I'm getting total events based on event types, blah blah blah, right? And then let's run it first on the analytics events table, right? So if you see, this took around like 200 to 300 seconds, 300 milliseconds, right? And then let's try to do the same thing on my public events. There should be some performance difference. Let's see. So if you see, this took around 697 milliseconds, right? So there is like a 2x performance improvement on million rows expected, right? Like obviously, I mean, once you have 10 billion rows, that will be 100x, right? Like so, this is the end-to-end demo where like we saw this NVMe-backed Postgres getting provisioned, right? Like with various profile types. We started within a few clicks, within few seconds, we started syncing our transactional data from Postgres to ClickHouse. And to close the loop, we had the PG ClickHouse extension to do both transactions and analytics, right? And the way we are positioning this product is, this is not a unified database, right? This is not like a uni store or a single store, right? This is a unified data stack. Each of them are separate, right? You basically get this toolkit. You get world-class OLTP, world-class OLAP, world-class CDC, world-class like unified query layer through PG ClickHouse. You pick and choose what you want, right? Like, so based on the use case, some customers might say that, hey, I don't want to use PG ClickHouse, right? Like, because going native to ClickHouse is much faster, so I'll just rely on CDC capabilities, right? Another customer we are working with, they are having a bunch of researchers in their orgs, right? These are like scientists, and they don't want to know what is Postgres, what is ClickHouse, right? Which is when they are exposing this PG ClickHouse, right? So what our positioning is a stack, right? In future we might get to that magical database, right? But as of now, it's a unified data stack where like these two amazing databases are as close as possible. So yeah, and last thing before I end the demo is I will also show you other things that come with the service. So if you see, basically if I go to this thing, it comes with all the standard Postgres managed service features. So it has backups, right? So you can actually do point in time recovery. So this is taking some time, it should load pretty soon. Okay, so it has backups, right? And then you can do point in time recovery anytime in the last 7 days, right? And you can pick and choose the days. And that 7 days also we can configure. If you want like more than 7 days, we can like do that as well. Read replicas, the standard, you can spin up like read replicas basically. We have monitoring, which I showed, right? And we have settings, which lets you, scale up, scale down, right? Like all the standard stuff, right? And all these platform features are only going to get better down the line, right? Like that PG-stat-ch that I showed, right? Which gives you that query performance insights, that will also be there, right? For example, I'll go to that talk. I do want to show that. I don't know everyone have seen. So this is the kind of metrics that PG-stat-ch extension gives you, right? So if you see, it has like queries per second, and all this is all via ClickHouse, right? So this all we want to bring to the Postgres managed service as well, right? And under the covers, this is not on Postgres. This is via ClickHouse. This is not like PG audit, right? Like which is on Postgres. It's not like that. It's basically going to ClickHouse, so it will be very fast, basically, and very minimal load on Postgres. So yeah, so that was the my talk. And last but not the least, currently it's in private preview, and if you want to try it out, please sign up, and we are very happy to give you access, and it's all free until beta. Beta, we plan to do it like in the coming couple of months, and it's all free, and happy to work with you and give you access. So yeah, that's it. Thank you.